Hey guys, we're back today learning more about mean absolute deviation. So if you did not watch the video from yesterday, even though I know it's a little bit long, I need you to go back and re-watch it today before moving on to the next part of the lesson. Otherwise, you will not be successful with the rest of the lesson today. So let's move into our goals. Today's goal is to understand vocabulary and to find the MAD of a set of data. So what is the MAD? Let's review. The mean absolute deviation of a data set measures the average distance between each value or data point and the mean or average. Our vocabulary that we need to remember for this week is mean and average, distance, absolute value, deviation, and variability. The mean should be familiar to you at this point. This is the typical or average number of a set of data. It tells you about what all the numbers represent. The distance is how far something is. There's no negative when it comes to distance, from point A to point B. It's how far away something is. It's a measurement of distance. Absolute value is the distance from a number to 0. So if you look or visualize a number line, how far a number is from 0, all you do is drop the symbol if there's a negative, or if it's a positive, it's obviously that number away from 0. Your deviation is how far each data set is away from the mean or the average. So once you find the mean, you can then figure out the distance from the mean to each data point by figuring out the difference or subtracting. You can think of this as how far from the target or the average score is that data point. And then finally, your variability describes the consistency of your data. So is your data consistent or is it all over the place? We'll get into that further today as we talk about high and low measure of absolute deviation. So how do we solve for MAD? There's 4 steps. First, we find the mean of a set of data by adding all of our data points and dividing by the number of data points we added. Step 2, find the distance from each of your data points to the mean. So after you find the mean in step 1, you're going to subtract the data point and the mean from each other. Once you subtract the mean and the data point, you're going to find the absolute value of that, or the deviation, how far that data point deviates or is away, the distance from the mean. Finally, to find the mean of your deviations, you are going to add them all and divide by the number of data points you added. So let's look at our example problem from yesterday. And if you're following along with me, awesome, because you can go ahead and check your answer from yesterday to see if you did it correctly. So step 1 of our data for Costco is selling hot dogs. Below is a list of number of hot dogs sold over a few days. To find the mean of this set of data, we need to find the total. So to do that, we add all of our numbers up and we get a total of 10,518. The number of data points that we added were 10. If we divide, our mean or our average is 1,051 and 8/10. That tells me on average, on an average day at Costco, they sell about 1,051 hot dogs and an eighth of one hot dog. Looking at my data points, now I'm going to find the difference from each of my data points to the mean. I'm going to go ahead and list all of my original data points, and then I'm going to fill in the mean of all of the rows because the mean column should be the same. To find the difference, I simply subtract. If you still are having trouble with subtracting from negatives, make sure to check your answer with a calculator before moving on to the next step. I will continue until I get through all 10 problems subtracting the data point from the mean. Let's quickly review how to find absolute value in case you forgot.
Math Shorts. Absolute value. The absolute value of a number is its distance from another number on a number line. Distance is a measurement that tells you how far you've gone from one point to another. The notation for absolute value is two straight lines, like this. The absolute value of 4 is 4, because 4 is 4 places from 0 on the number line. Negative 4 is also 4 places from 0 on the number line, so its absolute value is also 4. Absolute value is always a positive number because it's the distance from the other number, in this case 0, no matter the direction.
Now that we've reviewed absolute value, let's find the absolute value of our distances. You will notice if the number is a positive, it stays the same thing. If it's a negative, then all you do is drop the negative and write the whole number without the negative sign. Step 4 is to find the mean or average of those deviations. So now you're going to add up all of your deviations, how far each of those numbers were from 0. We get a total of 5,523 and 2/10. That's our total. And we again added 10 points. So that tells me that if we divide our total by our number of data points, our average or our mean absolute deviation is 552 and 32 tenths. Ignore the word average here. That's a typo. That should say absolute. So looking at this data point, 552 and 32 hundredths, that's a big MAD. That's a big mean absolute deviation. And what I mean by that is since the MAD is big, it implies that the mean is not a reliable indicator of the values. And let me explain a little bit about what that means. Here are our data points. So it's telling us that the average is 1,058 and 8/10. But if you look at our data, there's one day that's way lower than that, 818 lower. Another day is 1,314 higher. All of that information tells me that the data points are really far away from each other. They're not very close. If we would find the range of that, we would find that it would be almost 2,000. This means that the data is very different from each other. It's not the same. And there's lots of variations or variabilities, which means some of those numbers could have been an outlier that really skewed our mean, changing our MAD to a big number, something that's not reliable. This is not a good measure of central tendencies. I will get into that further at the end of the week, or at the end of the lesson. I apologize, the end of the lesson. But a big MAD is not what we're looking for here, because that tells me it's not reliable. Let's look at another set of data. Remember, step 1, we're going to find the mean. Add them up, get our total, divide by the number of numbers, and we have a mean of 89. When we find the difference of those numbers, we subtract the data point from the mean. And I will do that for all 8 problems. Then find the absolute value of each of those. This is probably the easiest step. Don't make this more complicated than it is. If it's -6, then the absolute value is simply 6. If it's 5, then the absolute value is 5. That's how far it is away from 0. Then, again, find the mean of the deviations now. So you're going to add up those numbers, which you get 22. We have 8 data points. If you notice, the data points don't change, so don't need to count them up again. Just look over here and you'll notice it's the same every time. So to find our mean absolute deviation, we divide the total by the number of data points, which would give us a mean absolute deviation of 2.75. Now, if you notice, that's way different than our previous mean absolute deviation that was over 500. So that tells me this deviation is small. This is a good measure of central tendencies. And we know that when a MAD is small, it implies that the mean of 89 that we solved in the first step is a good indicator of the rest of the values. So what exactly does that mean? Well, it means if I look at my data points, they're all fairly close to the number 89. The only ones that are a little bit different are 94 and 83. Those are a little bit further away, but still, most of our numbers are around 89. Those are the kinds of measures of central tendency that we're looking for because it tells us that the data points are close to each other, they're very similar, and there's not a lot of variation in that data. Let's review quickly. Remember to find the MAD, you add up all the data points and divide by the number of numbers. So you find the mean of that data. Then you subtract the mean and the original data points in order to find the deviations. To find the final deviations, you take the absolute value of them. And then finally, whatever your deviations are, you're going to add them up and divide by the number of data points, which is the same as the beginning, and find the mean of those. The last thing I want to review and make sure that you understand today is what exactly a measure of central tendency is. A measure of central tendency is a single value. So it could be the mean, the median, the mode, the range, or the MAD, but it's one data point. And that data point or value is an attempt to describe the entire set of data by identifying the central position or the middle of that data. So if you have a low MAD, this implies that the mean is close to all your data, just like in our example of 89. That was really close to all of our data points in those numbers. The data points are close to each other. They're similar data points. There's not a lot of variation. So as you can remember, the biggest variation was 6. That wasn't very high. And that means that you can use the mean to describe that. So you could say Sherlock's data is about 89 every day. Now, when we look at a high MAD, this implies that the mean isn't reliable representation of all the data points. So think back to our MAD of 551. That's a really big number. There's a lot of variations. That tells me the data points are really far away from each other. Tells me that there's very different data points. There's many variations. There could be numbers that were really high and numbers that were really low. And this tells me you can't use the mean as a valid measure of central tendency. You can't tell me that 1,051 hot dogs are about the average that Costco sells every day because the MAD was 551. That's about half. That's not a valid measure of central tendency. So when you're looking at a high MAD, you don't want to describe the data with the mean, but you may describe it with the median, mode, or range, depending on each answer that you would get. But the mean isn't a valid central tendency for you to use to describe that data. I hope I cleared that up a little bit for you guys today, and I hope that you understand the difference between a low and a high MAD. Continue on and do your practice problems for today. Remember to use the audio buttons to help you if you want the problems read to you.